This is our introduction to pneumatics. Pneumatics refers to tools that are powered by air rather than tools that are powered by electricity. They don't have an electrical motor in them because they have mechanical features that are actuated by air. Safety glasses are required and must be worn at all times. Hearing protection is recommended. This tool does generate loud and high-pitched noise during operation. Long or loose hair, neckties, and loose or baggy clothing must be contained. A dust mask or respirator may be required for some operations. Rings, watches, and loose jewelry should not be worn. So this is the air compressor system and the hookup. There's a valve. And then when the valve is at parallel with the pipe, that means it's open. When it's at 90 degrees, that means it's closed. And this is a standard plumbing configuration, so this applies to lots of things like your water main, your gas main, any type of plumbing valve. Perpendicular is closed, parallel is open. Over here we have a regulator, we have a conditioner. The conditioner also has a drain valve. When we turn this off at the end of the night, we come over here and we drain the air. Now the air is drained. We have to make sure that since we loosen this up, we now have to tighten it. Otherwise, when we turn it on, the air will just leak out. The valve is at 0 here. And when I come over here and I turn the pressure on, the air on, the valve goes up to, this is about 75 psi. 75 psi. Most tools want to run between 70 and 120 psi. The lower the pressure, the more challenging you're going to have driving some of the longer hardware with some of the pneumatic tools. I recommend being up at about 90, and this cranks one way and it increases the pressure. But I find 90 to 100 to be a good average pressure gauge. So normally we just leave it at 90 to 100. Many of the tools have some depth adjustment controls. It's better to do the control of your depth at the tool rather than to keep changing the level of the air pressure. If you keep changing the level of the air pressure, it affects everyone who uses the tool. So if multiple people are using the tool, you want the pressure to be consistent. We have 2 quick release connections here, and then down below we have a bin. We have blower nozzles, another blower nozzle. This is a pressure gauge adjuster. This is a T. You can put the T in, and now you can run 2 tools. We can use this to fill up the air on pneumatic tires, like on hand trucks and some other carts that might have inflatable tires. I've got another one here. We've got a pressure gauge. This will come up and give us our pressure reading. Upside down pressure reading. Another air filling tool. This little bin of tools is available right there for general usage. In the paint area, we have another hose connection. We have a very poorly coiled hose here. There's a second hose behind it that's all covered in paint. And then we have another valve and regulator here. Again, 90 degrees is off. Parallel with the pipe is on. This one has 1, 2, 3 hose connections. And it has a release gauge here. It looks like someone has cranked the pressure down to nothing, or the pressure gauge is, it's just cranked down to nothing. Never seen it cranked down to nothing. going to put that back up to 90 to 100. This one will get cranked down quite often because when we're doing pneumatic air spraying with the HVLP gun, you do want it between 15 and 25 psi. On the bottom here, there's a little lever, and when I turn this off, then when I want to drain it, I just turn that 90 degrees. And then again, I need to turn it back 90 degrees so that when I pressurize, it pressurizes. Our hookups are all quick connects, and all of the quick connects look something like that. The quick connect has a sheath, and you pull the sheath back, and you take the other end that's usually on the tool or on the end of the hose, you put it in, and then when it locks in, the sheath goes in and it locks together. This is easier to do when it is not pressurized. When it is pressurized, you're going to have a lot of air leaking out and trying to escape. It does not just snap in, although there are some new designs that are like that. All of ours are the older design. You actually have to physically pull the sheath back, hold it in together, and lock it. Hoses are usually stored hanging up on the hook right here. Go ahead and coil them properly and put them away every time. It is a little bit harder to do this when you have the air pressure on, and we have the air pressure on, so we have air feeding in here. So when I pull the sheath back and I put that in there, I just made it look super easy. It's not going to be that easy for most of you the first time out. And then when it comes out, that wants to shoot out, so you need to hold on to your hose when you take it apart. So another angle. That's how it goes, and that's how it comes apart. And again, that is how you're going to fight with it the first few times until you get the hang of it. Works the same in any combination. Works the same in any combination. But now that there's no air pressure here, this comes apart and doesn't do that loud noise. The air compressor is on the second floor in props and costume storage. There's a little bit of maintenance that we need to do on that periodically. Here's the compressor. Compressor has a certificate of when it was last inspected, and this certificate expires in 2022. Campus Facilities manages our permits for us. This compressor is running automatically all the time. It'll be continually charging. It's basically charging to fill this tank with air, and then we use the air in the scene shop as needed. But when we turn the valves off in the scene shop, there's no air flowing past the valve. So it's not continually putting pressure on the regulators and causing the air to leak out and the regulators to fail prematurely. This little red bucket down here is for draining the water out of the compressor. This should be done regularly, once a week or so. You can do it every day if you like, but someone needs to come up here and drain the water out. And you can see it hasn't been drained in a while. We've been off campus for several months. So there's going to be a lot of moisture in the bucket, in the tank. And what that moisture does is that gets pushed through the air line, and that moisture gets pushed through the tools themselves, and it dries out their gaskets, and it corrodes the insides. So we really want to keep this empty of water. So now that it's leaking out, I'm going to turn it off again when it's sputtering. I'm going to open it ever so slightly to try and get it to go even slower so I can get more of that water out. There we go. We got a nice slow trickle now. We'll go till that starts to sputter and we'll probably be good. You can take this water down and you can dump it in the sink or in the drain, or you can just leave it here and let it evaporate on its own. Either way is fine. Usually it isn't this much water. I'm going to do this one more time. Get a little more of that water out. That's going to be about the best I can do. So, at least once a week, the shop foreman, shop supervisor, crew lead should come up and drain this tank. Pre-operational safety checks. Air hoses must have a minimum rating of 150 psi or 150% of operational pressure, whichever is higher. If you are using 120 psi operating pressure, you need hoses rated at 180 psi. Most commercially available hoses are rated at 250 to 300 psi. Use 3/8 inch inside diameter hose for hose lengths of up to 25 feet. Tools will perform better when longer runs of up to 100 feet are using 1/2 inch inside diameter hoses or larger. Use only clean, dry, regulated air. Air should have all moisture removed. Inline lubrication on the air supply is allowed. Use the lowest air pressure that will do the job. Most tools have a safe operating range of between 70 and 120 psi. Most fastening tools work best in the 95 to 105 psi range. Most paint sprayers require much lower air pressure. All air hoses and connections should have an inline air regulator with a gauge to regulate the air pressure. All lines should be equipped with an air filter. Inspect and replace as needed. Systems should be designed with inline lubrication. Drops of pneumatic tool oil in the tool inlet are a good supplement to the inline lubrication system. Understand tool cycling systems. Full sequential refers to controls that have to be actuated in a series. First the safety tip, then the trigger action. This is also called single shot firing. Single sequential requires the same sequences as full sequential, but also allows you to keep the nose and safety device pressed to the material, and each subsequent trigger action will shoot new fasteners. Single actuation is the same as single sequential, except the first shot may be fired regardless of the order of action. Bump or contact will actuate regardless of trigger or safety sequence, and you can keep the trigger depressed and tap or bump for repeated firing. Dual trigger refers to tools that have interchangeable triggers to switch between cycling patterns. There are several diameter hoses, and they are measured by the inside diameter of the hose. This one is labeled 1/4 inch inside diameter. Right there, 1/4 inch ID. ID means inside diameter. Pipe in hosing is usually measured by the inside diameter, not by the outside diameter. It's the size of what it can carry, whether it's water or air or other substance. It is sized by the inside diameter. Now, the inside diameter of a 1/4 inch hose is going to be less effective at driving nails and staples than one that is bigger, such as this one that says 3/8 inch diameter, inside diameter. So when you're putting your flats together, you'll want to use the 3/8 inch diameter hose. They are just going to perform better long-term with your connections. If your hose length is running over 100 feet, you actually need to bump it up to 1/2 inch diameter. We don't have 1/2 inch diameter hoses. We're not usually going more than 50 feet. Most of these are about 50-foot hoses. Operational safety checks. These are safety checks you must be aware of at all times while using the tool. And you must check them and perform them every time you use the tool on every single operation or cut. All fastener tools should get a few drops of pneumatic tool oil in the air inlet at the start of each full workday or after 8 hours of usage. With all of the pneumatic tools, you need to know where the pneumatic tool oil is. And the recommendation is for all manufacturers is to put 3 drops of pneumatic tool oil into the air inlet at the start of every 8-hour day. So if you're doing a full day of production, you want to put 3 drops of oil in it at the start of the day. If you're just doing a couple of minutes of it and putting it away, you don't have to bother. But if there's been a lot of every day for a couple of minutes for 2 or 3 weeks, then someone needs to put in some of the pneumatic tool oil. There are different brands. Senko, this is Husky, this is the kind you can get from Home Depot. This is stored underneath the bottles of wood glue in the tool room. You take this and you put in 1, 2, 3 drops of oil. And you do that before you plug it in to the air supply. Always check the safety lockout features. Most fastening tools have a safety actuated tip that must be depressed before the tool will function. Some tools will have a lockout mechanism where the tool will not fire if too few fasteners are loaded or if the cartridge is empty. Some tools have a depth adjustment feature on the tool. Those that do not require depth adjustment by adjusting the air pressure. Always direct the exhaust port on the tool away from your eyes. Disconnect the tool from the air supply when it is not in use. Disconnect the tool from the air supply when loading or unloading fasteners. Disconnect the tool from the air supply before clearing a jam. Many tools have a quick release access feature to expedite clearing jams. Always remove fasteners and disengage the cartridge spring mechanism before clearing jams. Regularly check the tools for smooth trigger action and work contact element movement. These are potential hazards to be aware of while operating this tool. Fasteners may react unexpectedly, potentially firing through the material or out the sides of the work. Be careful that your hands and fingers are away from the places where this may occur. Ricocheting fasteners can cause injury. This tool may generate flying debris and airborne sawdust. High-pressure air is expelled from the exhaust ports. Direct them away from your face and eyes and away from your coworkers. Eye injuries are possible from flying debris. Noise levels can rise above 100 decibels. Protect your ears by wearing hearing protection while using this tool. Do not use faulty equipment. If something is not working properly, or if you suspect something is wrong with the tool or machine, please report this to your instructor and/or to the A&L technical director. Never operate with an air source that exceeds 175 psi. Never use high-pressure bottles or cylinders as your pressure source. Never use a flammable gas as a pressure source. Do not point the tool at a coworker at any time. Do not load or unload with your finger on the trigger. Never carry fastening tools with your finger on the trigger. Housekeeping. Wipe tools clean with clean, dry cloths before storing. Do not use chemical cleansers. Keep triggers and moving parts free of glue and dirt. Just like with your electrical cords and your audio cables, you want to learn how to coil your hoses properly. The 1/4-inch hose does kind of come apart in a mess. It's very lightweight, so it's attractive in its lightweight quality, which means you're not dragging along a heavy hose. But actually the heavier rubber hoses will perform better because they have a bigger inside diameter. This will be good for small projects, but not for large projects and big flat construction. The first thing you want to do is take out all of the kinks and twists and stuff. The easiest way to do that is just run it through your hands the whole length and just take out all the twists and kinks. And you might have to do this 2 or 3 times if it's a really badly twisted and kinked up hose. So there I did it once, I'm going to do it a second time just to get out some of the twists of the cable. You're going to start with one end of the hose. You're going to have to determine which direction and which left or right hand hold is the most comfortable. I hold it with my left hand and go like this. It doesn't feel right to hold it with my left hand and go this direction. And it doesn't feel right to hold it in my right hand and use my left in either direction either. So I'm going to do it all in this direction. So what you want to do is you want to start and hold it in one spot, and you want to consistently go down the length of the hose or cable, and you're consistently just going to the same length. So this distance is always the same. And then you just twist it in your hands one direction and meet your hand up there. And then if you want to do the over-under, you twist it in the other direction. And now I just go opposite directions, twisting one way and twisting the other way. This does not come naturally to anyone. So this does take practice, but a good time to start practicing is now, and with your air hoses and with your cables and lighting, your extension cords, everything. And that creates a nice bundled hose, and then it should have a tie line, and then you take the tie line and I do a bow tie, just like that. That is a good coil, and that is about the right size of a coil. You don't need to make it too tiny, you don't want to make it too big. This one's coiled nicely. This one's a disaster. So we're going to start over from scratch. I'm just going to get some of these kinks and twists out of this. It does take a little bit of patience. It does take a little OCD. And those things are really important in accuracy and cleanliness and repeated tasks. So embrace your OCD in the scene shop and in all of your backstage crafts. Sometimes you can twist it around like that to get some of the extra twists and kinks out. Do not be tempted to do this. This is not a good way to coil. What it does is it twists the cable together or hose together, and it does not make a nice, neat coil. Do not do that. Here we go again. Again, I'm just going to go down the same length. And sometimes if the hose doesn't want to go one way, it wants to go twice in the same direction, I don't fight it a whole lot. I don't force it. See, I just did 3 in the one direction, and before I'm going back in the over-under technique. Audio cable, it's a little more important that you do the over-under technique because, see, that one doesn't want to go that way, because the over-under technique causes it to uncoil evenly and not get knotted up and twisted up. An audio cable is more delicate, so you want it to not get broken or twisted or kinked and damaged, because that's going to produce really awful audio signal through your audio cable. But it's going to be hard to kink the air hose. Yet you'll see in a second a photo I found this summer of the air hose a machine shop. Well, I don't know how it was done, but it was twisted really badly. Always keep the tie line on the hose or the cable because it helps to bundle it up and make it a nice, neat bundle. And that looks much better. It's still a little bit weird, but this is one of the plastic hoses. This is also, I believe, 3/8 of an inch inside diameter. I can't see any markings on it, so it's hard to tell. It's pretty old, but it's a stiff, plasticky PVC material, and they're cheaper, but they're a little bit more frustrating to work with sometimes. We do have this portable air compressor. It's useful if you need to do some on-site pneumatic work, either on the stage or on one of the other stages, and like in the arena. It is not a good production machine. It only has this small tank, and you saw how big the other tank was. So it can't do a lot of repeated staples over and over again. You can't have 2 or 3 tools attached to it, building flats. It does have 2 gauges, one for the tank pressure and one for your outlet pressure. It has an air release valve here, so when you're done, you can release the air. It has underneath, it has a drain valve here for draining the water out, just like the other air compressor. Electricity plugs in, 110 volts, nothing fancy. If you have to go onto a set and you have to attach a bunch of molding and you want to cut it and attach it right then and there, you want to make fewer trips back and forth to the shop, you don't want to run a hose all the way out there, you want the air compressor right on site, this is your little tool, handy tool to do that. So more options available for you.